So for chapter 7 here, um, I think chapter 7, the big idea is that the sample mean, x bar, excuse me, you know how to calculate the mean, it just means add them all up, divide by how many there are. It has a standard deviation that looks slightly different. You take the standard deviation of the data set, but then divide it by the square root of the sample size. Okay, and then another big takeaway about the sample mean is that with a big enough sample size, usually we try to shoot for 30 or more, but sometimes you need more than that. With a big enough sample size, it makes a bell-shaped curve. Okay, so let's check out this problem here. Excuse me. Manufacturing company studied the rate of production for lumber. A mean of 29 days with a standard deviation of 9 days. So the company plans to take a random sample of 34. That means n equals 34. So square root of 34 here. And then S, the standard deviation, is 9. Okay, so we got to compute that to figure out what the standard error of the mean is. Okay, because the means distribution isn't going to have a standard deviation of 9. It's going to have 9 divided by the square root of 34. So this bottom is 5.83. So if I take 9 divided by that bottom, we get about 1.54. I think it says round to the nearest tenth. So I'm going to go 1.5 for my standard deviation. Let's see, it said it had a mean of 29, so the center of our distribution is still at 29. But instead of having a standard deviation of 9, it has a standard deviation of, what would I say here? 1.5. Oh, 1.5. Okay, let's see what else. Okay, yeah, so now that we know that the mean is normally distributed, means you can convert it into a z-score and then use this table for z-score values. It's like it helps you calculate probabilities. Okay, so what's the probability that the sample mean for sample size of 34, like we just had there? Let me write down the standard error before I forget. 1.54. That was our standard error. Probability the sample mean for sample size of 34 will be more than 32. Okay, so if you draw that distribution that we just had, the mean was, what did we say? The mean's 29. So we want the probability that the mean for the sample size is greater than 32. So that means it should be less than 50%. Because right at the center, right at the mean, that's the 50% cutoff. For it to be more than 32, that's definitely going to be a chunk that's less than 50%. So to find out what that is, we have to calculate a z-score, and then we can use the z-score table to find the probability. And a z-score is just the number you're trying to test subtracted by the mean, and then divide by the standard deviation. Now in this case, it's slightly different because we're talking about a sample mean, okay? So the number we're trying to test is 32. That goes in for x. The mean that we have, the mean of our distribution is 29. Oh, there we go. And the standard deviation we have is 1.54, etc., etc. So I'm going to type that. 1.5435 is probably all the decimal places we need. Make sure you don't use 9 because they're asking for a mean. The mean has this different standard deviation. The data set has a standard deviation of 9. The mean has the standard deviation of 1.543. So that's why we call it different. We call it the standard error. 32 subtracted by 29 divided by 1.5435, a z-score of 1.94. Okay? Z-score tables just have 2 decimal places. So if you look at 1.94 here, here's 1.9 and 1.94 gets us at 0.9738. But that contradicts what we just said over here. 97.38 We said it's supposed to be less than 50%. That's because the z-score table tells you probabilities that are to the left. So 0.9738 is to the left. To find out the area to the right, the whole area adds up to 1. So if you subtract it by 0.9738, 0.0262, that's the probability of being greater than. So they want it as a percentage to the nearest percent. 2.62, that rounds up to 3%.